Every day, whether we realize it or not, we experience weather. From warm sunshine to cold rain, from snow-covered streets to intense thunderstorms, weather shapes our lives, our safety, our food, and even our mood. But have you ever stopped to wonder, what causes weather? What are the forces that turn invisible air into wind, water vapor into clouds, and temperature into thunder and lightning? Let's take a journey into the atmosphere and uncover the invisible engine behind Earth's weather. Weather starts with one simple but powerful source: the sun. The sun sends energy to Earth in the form of solar radiation, light and heat. But the Earth doesn't absorb this energy evenly. The equator receives direct sunlight year-round while the poles get much less. This uneven heating creates temperature differences across the planet, and from this imbalance, everything begins. Wind is just air moving from high pressure to low pressure, trying to balance things out. The greater the pressure difference, the stronger the wind. So when you feel the wind on your face, you're really feeling Earth's natural balancing act in motion. But wind doesn't just flow in a straight line. Earth is spinning, and that spin changes everything. This is called the Coriolis effect. Because of Earth's rotation, winds bend to the right in the northern hemisphere and to the left in the southern hemisphere. This gives rise to the major wind belts of the planet, like the trade winds, westerlies and polar easterlies, which steer global weather systems. Now let's add water into the equation. When the sun heats oceans, lakes, and rivers, some of the water turns into vapor, a process called evaporation. Plants also release moisture through transpiration. This water vapor rises with warm air. As it goes higher into the atmosphere, the air gets cooler, and cooler air can't hold as much moisture. Eventually, the vapor condenses into tiny water droplets. These droplets group together to form clouds. When enough water droplets gather in the cloud, they become too heavy to stay suspended in the air. Gravity takes over. The droplets fall to the ground as precipitation, rain, snow, sleet, or hail, depending on the temperature. This is how the water that evaporated returns to Earth. This continuous cycling of water through evaporation, condensation, and precipitation is part of the water cycle, and it's one of the engines behind daily weather. One of the biggest triggers for active weather is when different air masses meet. An air mass is a large body of air with the same temperature and moisture level. When two air masses with different characteristics meet, the boundary between them is called a front. A cold front is when cold air pushes under warm air. It often brings thunderstorms, heavy rain, or even snow. A warm front is when warm air slowly slides over cold air. This brings steady rain or drizzle and then warmer weather. Stationary fronts occur when neither air mass moves, often causing days of cloudy or rainy weather. These clashes between air masses are where much of our dramatic weather is born. When the atmosphere becomes unstable, meaning warm, moist air is trapped under cool, dry air, it can explode into powerful storms. Thunderstorms are created when rising warm air carries moisture high into the sky, creating towering clouds called cumulonimbus. Inside, strong updrafts and downdrafts create lightning, thunder, and heavy rain. In some cases, storms become even more organized and intense. Tornadoes form from rotating air columns inside severe thunderstorms. Hurricanes form over warm oceans, where rising air and Earth's rotation generate spinning storms that can grow into massive, deadly systems. All of these events are powered by the same core ingredients: heat, moisture, air pressure, and motion. It's important to remember weather is what we experience day to day: sunshine, rain, storms, wind. Climate is the long-term pattern of weather in a region. You can think of weather as a single page and climate as the entire book. So when we talk about global warming, we're talking about changes in climate, not just changes in day-to-day weather. Local geography also plays a huge role in shaping weather. Oceans, for example, moderate temperature and increase humidity, often bringing more rain to coastal areas. Mountains force air to rise, cool, and drop moisture on one side, creating rain shadows on the other. Cities, absorb more heat due to asphalt and concrete, creating urban heat islands. Forests increase transpiration and can even create their own microclimates. So, while global systems guide large-scale weather, local conditions really fine-tune what we experience in our towns and cities. Weather prediction has come a long way. Today's meteorologists use satellites to see cloud patterns, radars to track storms and precipitation, weather balloons to measure temperature, humidity, and wind at different altitudes, and computer models that simulate the atmosphere's movements. These tools allow us to predict weather with remarkable accuracy, though honestly, the atmosphere's complexity means we still can't always get it right. Weather affects nearly every part of life: what crops we grow, when animals migrate, how we build homes, where we vacation, and how we prepare for disasters. Understanding weather helps us stay safe, feed communities, and adapt to changing conditions. It connects us all, no matter where we live. So what causes weather? It's the sun's energy, the movement of air, the spinning of the earth, and the dance of water vapor in the sky. It's a system in motion, a rhythm of nature that never stops. The sky above us may look calm, but it's alive, with forces we barely see, but always feel. Weather is the story of the air, the land, and the sea, written in clouds, told in wind, and brought to life every day. Thanks for watching. Stay curious, stay prepared, stay connected to nature,